This talk, I am going to talking about a enterprise distributed package that comes with IBM. And we did some survey earlier. It seems like that a lot of people from the audience seems like would like to go back to some basic about machine learning and some information like that. So for you, it may be just like so elementary for you. So I won't feel bad if you just walk. So like I said, I will introduce you about the package, and I will give a demo, a very quick demo about TensorFlow, and then I will try to go in. This session will have a hands-on lab. Unfortunately, I only have 10 user ID here, so maybe some of us we will share. But I tend to do it in two different frameworks, so that introducing the audience with one framework from Google and one framework from Facebook.
Oh, we have two company members.
I know. So the Power AI is, as I said, is an enterprise software distributed package that you can download. So what are included in this package? It includes the commonly used framework. We talked about it all this morning that at this time of the state, not a lot of time starting from scratch, unless you are in a very new area, the explorationary area. It doesn't make sense to start from scratch. It always pick up the work from somewhere, or some researcher have already done that, some corporate already done that, and enhance and using that as a base and go from there if it works. So in terms of deep learning network framework, we have this morning, we showed that there's about 15 of them. So far, it seems like the popular one would be, of course, TensorFlow has been open source since 1915. It's one of the more mature one in terms of open source. And the next one would be like Caffe and PyTorch. In this session, we're talking about, we touch about TensorFlow and then we'll talk about PyTorch. For this package, if you want to get it, where do you get it? I have 3 links here. You can get it as a software for you to install, or you can get it as a Docker container, and we might demonstrate how to get it as a Docker container there. So to learn more about the Power product family, I have the link here. I am not going to spend time go to each one of them, but you can go to this link here and exploring. I want to spend a lot of time here for the hands-on session. So one of the things that I'm going to show you is if you go to this this address here, you could get one of the container down, and once you get that container spin up, then you should have both TensorFlow, all the framework ready for you. And the way you enable, once you get the container, the way you enable, for example, you want to enable TensorFlow, then you can just go to do this statement here, source TensorFlow, or you can activate PyTorch as well. So for that, I think I'm going to try to give you a demo of how to do that. I am logging in one of the system in University of Oregon, and so that is just a gateway. So here I am actually getting into a Power9 system. So on this system here, I've done this before, so I just recall that command that I use. So you will spin up anyone using Docker image here? Anyone available? Yeah. So for you, you can just go there, go to that address, and of course, right now on the website there is package for PPC, which is open power architecture. There also x86. So you have to choose based on your whole system. You choose whatever is appropriate for you, and you just bring down one of the image. Okay, so the container is up right now. Right now I am inside the container. So I will demonstrate to you that if I go ahead and do something like import torch, which is PyTorch. You will see that it's not available. So what I will do is enable it. So I source it, and now I can, so that means that PyTorch is now in the environment. So you did not, with bringing down this container, you do not have to install PyTorch. You also do not have to, if you choose to use PyTorch, or you can also choose to enable TensorFlow, for example. So that talk about, I just give you some introduction about a package that you can download, and it will save you all this time of installing the framework. Okay. So I think all morning today we talk a lot about neural network. I don't think I need to repeat that, but I will just stress on something that we may be able to go through when we do the exercise. So just keep in mind a neural network, or we talk about what is the difference between deep learning and also ML again. In deep learning, after all, a model is just a set of mathematical expression, calculation. Whether you have one equation or 100 equation, that is the level of deepness. The more level of operation, math operation you have, the more intense the computational power you need to have. That's why in the past, the deep learning, neural network explore and develop now because of the computational powers has become tremendously powerful right now. So that the amount of computational is less as a concern as what we had before. But after all, it's just a set of math expression, and you have data coming in, so you always have whatever your data, and you always have what expected, which is what we call the target or the label. So you have data and then you have label. You try to learn to teach whatever this algorithm that you want to do, so that when you input this data, it match whatever your output. And because of that, in the future, when you have a set of data that you don't have a label, you can predict what it is. So that is a neural network in a very common way of describing it. So most of the time, we see the formula. You would usually see a linear equation, but you know the word is not linear. And therefore, you have something called activation engine. That activation function actually doing the transformation of that linear question or linear domain into a non-linear word. The word is non-linear, and that's how we represent it. As we go through the exercise, I will go through more about the equation, also the activation engine as we go along. And then we're talking about we optimize the model. What does it mean by optimize the model? What usually in math, a linear equation, I guess everyone know y equal to wx plus b. So that is a linear equation. And usually in math, what is our unknown in that equation? X, right? Y equal wx plus b, right? Usually in our equation, in our math, x is the input data, y is the unknown, and I'm sorry, y is the unknown. So we use x, we have x and we calculate y. However, in neural network, we talked about earlier, what we have is x. We also have y, but we don't have w, we don't have b. And that is what we're trying to find out. When we say we train a neural network, what we're trying to do is define what is that w and what is that b. So, so how do we define that w and b? We will use something called, we will first assign it some random number. Assign it some random number. Then we pass our x through our input into this model or equation. And then we get a y. That's what is by purely mathematical calculation. And then we use that y, we compare to the y that we know, and we see how different that is. And that is what, when we try to see the difference, that is what we call the loss function. We see how far is it from there. Once we know the loss is so far, what we're trying to do is adjust the w so that we make the loss between the difference between x and y smaller. That whole thing is called training. And how do we twist the w? What kind of methodology we can use that when we do the hands-on? I'll show one or two of the methodology that we use. Usually we use something called gradient descent. Again, iterate. What is a training flow? When we train a neural network, what do we mean? We have an input data. Again, we have input data. We have a target output data. We pass our data into a model. A model is just a math expression. And then we get an output. If we stop right there, that is what we call inference. That is the result why we train a model. We train a model so that in the future we have an x, we know what is y, we calculate is y. So if we stop right there, that is what the application will use. But in this case, we don't know, our y is so far away from our target. So what we need to train, in training, we calculate the loss. As I said before, we calculate the difference between the y and the target y, and then we adjust the weight. Here is weight is a w and the b. So that is the whole training flow. Okay, so we want to look at one of the Tensorflow workload. So at this point, we talked about training flow already. Do you feel like at this point you would rather go into the exercise, the hands-on exercise, so we can explore more on the concept that we just talked about, or would you rather we go through the presentation and then go back to do the exercise? What do you prefer?
Presentation.
You prefer to go to the presentation? Okay, so now, one of the first applications we talk about is the MNIST. Again, MNIST is like the hello world of the neural network training. So in the MNIST, or what we call is recognized handwritten digit. So we have a set. This morning we're talking about 60K image of handwritten digit data set. That is what we will use as our input data. So in the data set, there is 0 to 9 digits. So and then it is all kind of is all kind of handwritten. People write image differently, and that's what we have. And how do we represent when we say data? It's not a, it is a JPEG, but how do we transform that in a way that the computational can consume that? So we typically take an image and transform that into what we call high dimensional array or matrix. And this image here, this image we're talking about image is, in this image is 28 by 28. This morning we're talking about the food image is 600 something times something. So those are the pixels. So we represent pixel in numerically, and that represent what is the data that we're going to input into our equation. So what you can see here in terms of math, it is a matrix.
So do the numbers represent the contrast?
The intensity
Intensity.
of that. You can see like on this one here, and this one here is a 0.6, right? As you go, so intensity for this package of number is just a black and white. It doesn't have RBG, so it's just black and white data set. Okay, so we at this GitHub here, we have Paul is one person in our area, so we have one GitHub. But this kind of sample you can have anywhere. But you can go to this GitHub and download it, and then also try it. So what I am going to go to show you that the container that I create earlier. So first of all, I need to go and download the data from GitHub. But I know that this one doesn't have Git installed. So the first thing I need to do is install it. And then I will install Git. And then try to run that for you to have a feel. What does that mean by image recognition? And when we get to the Jupyter Notebook, then you will have a chance to do hands-on. So now it's just to demo the concept of the package. Yes.
While you're installing, I have a quick question.
Yes.
You know that game where people like draw like an image and everyone else tries to guess like what image that is? Is the technology out there today to have an AI win that game?
I am not quite sure about the dynamic. Like when you say someone draw right away, image recognition, this application is a static, is a snapshot representing a static picture that you will feed. Then you take that picture, you transform that into a tensor as we see it, and then feed in. Yes, it's a form of image recognition, but there's a lot of pre-data processing before you get to the point where you input the data to the model.
Got it.
Does that answer the question?
Yeah, the answer is no, we don't have the technology to have an AI win that game.
They do, I think so. That's why when you do, But I'm saying that up to the point that image recognition, there's a lot of work have to be done before you recognize the object.
Right.
Yeah.
Google has one, so
Yes.
where you draw and then Google AI tries to guess what image
But-
it is.
Nice.
But that's not, maybe I don't understand the question, but what I'm saying is at the point that you do image recognition, there's a lot of the data collection, data prep before you feed into the model. That's it. But the application exists today. Okay, so I just need to install that. What is that?
You came out of the docker.
Huh?
You came out of it.
Oh, I came out. Oh no, I may be not at the right. I'm not at the right place. Yeah. So processing. Yeah. Thank you. Yeah, I was on my Mac. Could not create work tree. Oh, because I'm not. I am on root. So I download the. So earlier I talked about there's a couple students here. So student asking like, how do you go and show people your work? I feel like one of the good way is have whatever you work in GitHub and point your people to your GitHub, and then people can just use it, just like what I did here. So in here, there's a code. So you can download this code. No file directory. What's that? Oh. So in here, there's a code of the MNIST code. In here, you can go there and try it. But one of the things that I'm going to run. So here, what it does is actually, in this code, is actually go to the MNIST dataset, get the dataset down, and here is just a very simple one linear layer and just softmax. For the idea of make it easier for us to explain the concept. So now the model is safe. Of course, this is it's just some model. It's not going to be the best. And now I'm going to use that DOM model to show how. So I'm going to use that model to predict one of the image that we have in there. So earlier we talked about this concept of data for training and test data. Typically, the data that you use to train should not be the data that you use to test, because when you train with that program know about that data already. So typically in a inference, so now I already have the model. If you recall, I saved the model in a direction somewhere. And I take that model, I input an image, and I ask it, what is that image? The image that I input is image 1. And if you go to, if I go to, I don't remember what is TFM is.
Tensorflow.
Yeah, it's not a TensorFlow because
Yam is spelling mistake. Yam, it's not.
yeah. So you can see that in this image, the image number 1 is number 2, and on the program, we predict 2 will have 99% of chances 2, and 3 whatever. So that's how image recognition works. Okay. So now I'm going to explain that reinforce that concept again. So the concept is we have a data input. So in this case, data input is a matrix or a high dimensional array of X, and you try to learn your W and your bias, and with that that is a linear domain, problem domain, but in the word, you're going to you squash it to make it become a finite number. For example, in softmax, what you want to do is make it become a limited number called class. Whether you have, in this case, we have class of 10 digits. So you put on that, and what you calculate here at the end is a probability of a 10 number. So like we said earlier, if number 2 is your answer, that probability, that number of probability should be the highest. So again, a neural network is some kind of math expression that it takes your input data, do some math calculation, one layer, maybe more than one layer, get eventually, before you get the output, go through some nonlinear transformation and get the output. That is your neural network. Okay, so in the next few charts, we're talking about how we enter these numbers in TensorFlow. So now we talk very specifically about programming a language of TensorFlow. Do we interesting in that? Maybe I go through very quick, and then we can go to a hands-on section. So remember that we have an xy. In this domain, xy is not our variable. Remember, I was saying what we try to learn is W and B. So in TensorFlow, the data, the way that we define xy is called placeholder. So we'll create placeholder for our x and y, and here are the way that you define it. In here, the dimensional, when you define your data, dimensional is very important. As you recall from here, when matrix multiplication, if for example, this is a 3 by 3 times 3 by 1, it works. But if you have a 3 by 3 and this one is 1 by 3, it won't work. So dimensional. So again, a question is, as a deep neural network developer, do we really need all these math? Do we need to be really math? And for me, if you are really in researching, you are the one who define the model. Yes, you do. But if you are the one that was trying to optimize the rest of the area, but outside of this model, for example, how do you scale this this model? How do you segment your data analysis? How do you batch your data? So the question is, for anyone to get into the AI, as an AI developer, there's different area that we can work on. There's some area that really need your math expertise. There's some area you just need to understand. A lot of time you probably need to know the formula, but some framework already implement the formula for you. But you do need to realize what this formula does, for example. And the opportunity is in different area. You agree? Yeah, it's not like in order to get into an AI, really need to be really good in math. good in math always help, but you still can have some area that you can work in. So that's how you do the placeholder. And then when you define the weight becomes your variable. And usually in your programming, we define X variable. Variable is something that we want to define. In this case, the weight and the buyer is the variable that we want to define. And you also want to initialize it with something, and that's why you see this truncated number. You initialize it with a Gaussian distribution number in your weight, etc. And then finally, here is your model. I mean, it is a very simple model, but earlier I showed you that it actually worked to some extent. And we purposely make it simple so that to convey the idea of what is a model. And the model here is just do a matrix multiplication of x to y and add b. And then pass the output to a softmax. So softmax is just squash the number, become whatever number of classification that you want. So at the very end of this presentation, I have the softmax formula for you there. So if you can see, the softmax formula is just e to y to the I to the sum of e to the y of I from 0 to whatever number. So all it is, if you think about it, it's kind of like a percentage of probability of the individual to the whole. So that is softmax. But you use exponential so that you limit it, the number so that it won't be some number that that is like infinity or something. So so go back to here. So you define your, and then you define your model, and then we talk about loss. Again, loss is measuring the difference between your what you calculate. Out here you get a output. That output is y. And you have this y underscore, this is your target. You know this x, the output should be this y underscore. So that is y underscore. In this formula here, the cross entropy formula, you try to compare the difference between your target y and your calculate y. Again, the formula is you take log of whatever you calculate, and then you time your target, you sum of that and divide by, normalize it to the sample. Again, there is a lot of mathematicians, very smart people already define all of these formulas for us. We just need to know what are they for and why are they in there. So, so the one that, the program I just showed you is just one layer. And of course, we talk about CNN all morning. The one layer, if you see, we take 28 times 28, we flat it out to 7, whatever the numbers, 784 or something. But then what we losing there is a spatial difference. You write a 1 here versus 1 here. When you're flattening out that matrix, you don't see that. So again, you have all these different other technique. We talk about this all morning, called CNN and all of that technique. And then we have a lot, again, go back to a lot of people already stack all these different formula on top of it and create something called LearnNet, ResNet, and etc. So these are the, so we have a lot of knowledge right now in terms of image recognition. Okay, so that is how much I'm going to talk about TensorFlow. And I think we have a few audience in here that know about TensorFlow. So next, we will talk about PyTorch. So PyTorch is based on Torch from Facebook. And PyTorch is a Python based, whereas Torch is a Lucia based, a different interpret language. And I guess it's not as popular as Python, and that's why, therefore, PyTorch. And I feel like TensorFlow and PyTorch is the 1 and 2 framework for deep learning at this moment. TensorFlow being, I think, is a lot more mature, a lot more contributor than to PyTorch. So what is the strength of PyTorch? And typically, the way I see is a lot of NLU space of application or researcher is using PyTorch, where a lot of the imaging area is on TensorFlow. For example, Baidu's speech recognition was started from TensorFlow but has migrated to PyTorch. And it is relatively new. It is only about 2 years old, open source right now. And the key of that is it has this dynamic computational graph. Unlike TensorFlow, in the past, you would define the graph and create a session and then run it. In PyTorch, you define the session and then you run it as just like your Python program, one by one. However, since last year, TensorFlow also come out with TensorFlow Eco Mode, which is also having dynamic computational graph feature. But PyTorch, when first start, this is the feature why people like it, especially the researcher and people who do prototyping, because you can code a line and you run your Python interpret to that line and it execute that line. You don't have to define all the graph and then run it as a session later. And it is a native Python package, and it's also doing also differentiation. Think about, we talked about earlier, you adjust your weight. You adjust your weight by calculating your derivative and gradient. And this Python will do automatically whenever you define a math operation. It will do the gradient calculation for you. However, TensorFlow also have it today. So the world is smashing and become very smaller. It's not a lot of difference right now. And it will merge Cafe 2 and etc. The two major classes in PyTorch, one is the tensor. Again, you need to represent your data as a tensor, a high dimensional array. The one thing that special about PyTorch is when you define a tensor, you can specify this tensor running in CPU or GPU. That is one thing that we haven't seen in TensorFlow. I think in the future, right now you either have TensorFlow CPU or TensorFlow GPU. But in PyTorch, it's just one. At runtime, you define, now I want it run on CPU, now I run it on GPU. But I'm pretty sure TensorFlow will come up with that kind of mode. And then there's a module. It's a high-level abstraction of your model, whether you are a linear model or you are a CNN model. In TensorFlow, this type of layer reside in Keras. So you have to have TensorFlow, and then you have Keras on top. In PyTorch, it's just in PyTorch. Okay, so that is how much I'm going to talk about PyTorch, and now we can go into a Jupyter Notebook and take a look at some of the PyTorch operation. I only have 10 instances right now on PyTorch. So yeah, I only have maybe not enough, but just share. More important, you just need the address.
We should do pair programming.
I have the other container. I did download that.
Oh, is it?
Yeah. All you need is just the address. All you need is just the address. You don't need that.
We can take photos of it, cheap, right?
Yeah, you just need the address.
You can add it.
Sure, take it. Yes, take a photograph. You took it. Yes, take
Yeah,
it.
all you need is the address.
Oh, okay, no,
Is it boring for you? So now is a hands-on session. So on your handout, you will have the last four digits of the port 888, right? 888 and question mark. Okay. So I have from 1 to 9.
Well, come, sit down.
No, so you have the, you get the.
Yeah. I have the image.
You want?
Right. So the port, right now, I think they're 888, right? And then question mark.
Yeah, it's 889 and question mark.
Yeah, 889 and question mark. So I guess I only have 9. So is 8891. You may be 91 then?
Yeah. Yes, see,
You're 91.
Okay.
Yes, Kevin.
You're
Oh, the
91.
question mark stands for 1. Okay.
Yeah.
Yes,
Okay.
Kevin.
And I only have up to 9.
Sorry,
So 1
we should have
to
written
9.
this.
So
Yes, Kevin.
1, 2, and you are 3. You 3. And do you want to try? 4. You X. 4. You're 4. 5. 6. 7. You're 7. 8897. So we have 2 more. Whoever.
So I'll take 8. I'll take number 8.
8 and then you 9. So we would have. Okay.
Single line.
You want to try it?
So you got
What the
the
password again?
workshop.
Okay.
This
Cool.
workshop. I think 889 I use already. You already have data down. Oh no, you don't have. 1 I haven't touched. 9 already have data download. So you will run very fast. Okay. Okay. So right now I have 4. I don't know what the audience are. So I have 4 different level of Python of notebook in there. So for this class, after the survey, I think we're going to go to PyTorch introduction. Let's go to PyTorch introduction. Okay. So now, so everyone get it?
What's the password?
A workshop. So I hope that the people who use TensorFlow appreciate the eco mode of it. Okay. So on the first one, I'm going to go through, you can go ahead and run, but I'm going to go through and explain to you what it does. So on the first one, as we said, the first, if you remember the flow that we do, I'm going to go refer back to this flow a lot and point it to you that which state we are in, this flow here. So the first state is input data. How do we deal with our input data? So in there, so we, again, everything is a tensor. Tensor is just a high-dimensional array. If everyone know about Python, then it's just like NumPy array. If you are familiar with NumPy, it's NumPy array. And in here, if you, again, I give you different way of define a PyTorch. What I hope is, if you have used TensorFlow before, by using this notebook, you can map it like very quickly. If I want to create a tensor, how do you? So I try to put in all the normally, commonly used syntax in here. Of course, it's not complete. It's just enough for us to describe what's going on next. So the first field is, again, it's like the name say, torch.0. You initialize, you create a tensor of dimensional 2, 3, a matrix 2 by 3, and initialize to 0 to 1, and empty, not initialize or initialize with a random number or etc. So I also give you the default data type, that this kind default, what kind of data type is there. The second group of tensor is, I want to create a tensor. On the first one is a 2 by 3, right? But I also want to initialize to the number that I want to initialize. For example, first one is 2, 3, 4, and that's the syntax. So again, here I'm just telling you how to define a tensor in PyTorch. You can go ahead and run it. So you go ahead and run by just do a run. And in, I don't know whether everyone knows Jupyter Notebook. In Jupyter Notebook, when you see a number appear here, that means that it finished running. Okay? So here, the last one is this display for you there. The next one, which is what the things that I talk about, kind of the strength of PyTorch is, in a tensor, I have a lot of attribute about that tensor. One of the attribute is divide type. Everyone have to have divide type. TensorFlow have divide type. Data type. But device type is something that very, at least 2 years ago, is very new to TensorFlow. This device, you can divide it as a CPU device or a GPU device. If you divide, you decide that at a CPU device, everything will run on CPU. If you say that it's GPU, everything is GPU. However, when you do computational, you remember you do X times W. If X is in GPU, W has to be, they have to agree. So you just have to, there's a lot of things that I go through. I'll point you, here is one we switch that to CPU and GPU, etc. And remember when I say require, you need to calculate gradient. Later I have an explanation. What is a gradient for you? But just remember that when we have a flat here, when you say require gradient, that means that every math operation that I operate on this tensor, you go ahead and record all the operation for me because I may do backward propagation later. So when I set this on, it will record all my operation. If I don't set it, then it won't. Think about the case, at what point you don't set it? When you do inference, you don't set it. Because you are not going to do backward propagation. So when you do inference, you don't set your this. So you have all the freedom to manipulate your data whatever way you want to do. So on the first one, I create a tensor, and I don't define anything. So the default will be CPU, the default will be not create, etc. So the first section, that's what I want to show you. The second section here, I try to show you how do you define this device. The device, there's only two options of the device. Maybe later there will be a third option called TPUs. But at this moment, it's either CPU or GPU. So here I say towards device CPU. That means this device right now is CPU. And then X, you remember I defined X earlier, and X is already my tensor. I create that tensor without specify device. That means that device will be CPU. And now I turn it into GPU. Okay? And then the third one, what I show you is you could, at the time that you creation, specify that I want to create as a GPU. And then once that, after that, I can move it from GPU to CPU. Go ahead and run it. Is this too slow? I mean, should, yeah, I don't know whether I have enough time. Okay, so look at the output. Look at the output. The first output on my screen here, I show you, you don't see a label of device. When you don't see device equal to what? That is CPU. Okay. The second one, you remember, I turned that X into CPU. Now it tells me that you are running on CUDA 0. Because there's a lot of the time you might have different CUDA. You might have 4 CUDA in your system. So it will tell you that in this case, where do you run? And then on the last one here, if you recall that I turned it from GPU to CPU, and now it doesn't show. So whenever you do a print tensor, it doesn't show your device is a CPU. Okay. And now we're going to look at required grad at the same thing again. Sometimes you will need to create the gradient. Sometimes you don't. Okay, if I have a formula y equal to x squared, think about it. Y equal to x squared. What is the derivative of dy over dx.
2x.
2x, okay? 2x. So think here. So now my y here is my out, okay? So power 2 means that now y equal to x squared, okay? And I did not do a calculation here. Later I do the calculation to show you the calculation from, you can do a hand calculation. That's why we need framework. If everyone have to do all the y equal to x squared is very easy. But if you have a more complicated function, then that's why you need a framework. A framework will do a lot of these gradient calculation for you. So in here, what I do is when I say gradient equal to false, mean I don't want gradient, and go ahead and run it and then see what is the printout. To print out, say gradient function none. You did not ask me to create. I don't know your value, etc. So now on the next section, I will set the gradient equal to true, and go ahead and run it, and then you will see. Now on your gradient, remember, you only have gradient when you do a math operation. That's why the gradient with respect to x, at that point you don't have math, so there's no gradient. But when you say gradient of y, which is out with respect to x, because y is a calculated entity, that's why you have it. And that's why it's print out, okay? Okay. So one of the things that, so one of the strength of PyTorch is all these tensor manipulation. So you can go it from GPU, CPU, etc. But the whole world has been built on CPU to begin with. What do I do with all these tools that already built with CPU? And typically in a neural network is NumPy, is that package. So PyTorch have this thing called conversion from NumPy array into PyTorch tensor or tensor to NumPy array, vice versa. So that is what we demonstrate here. The reason to have this so that you will still be able to use all of your utility, all of the packages that have been built earlier. You don't need to build from scratch. So on here, the first line here, I create a NumPy array, and then I convert that NumPy array become a tensor, and then I also from tensor to NumPy array, etc. So go ahead and run it. Then you see that in PyTorch, when you do a print, it gives you the label. If an array, that's a NumPy array. If it's tensor, it's a PyTorch tensor. So those are just for you to see that. Okay, so now we have the basic of the, go back to this presentation. We take care of this box. We have this input data. We know how to manipulate that. Now, how do we go to do a model, go to our model? So again, we talk about that you have some data. In order for you to learn something, you need to know what is it and what do you learn. You say this is a picture of the cat. Someone have to tell you this is a cat to begin with. Then next time you see a picture of a cat, you know it's a cat. So this kind of learning, you have an input and then you know the output, what we call is supervised learning. And there is also unsupervised learning, but here we talk about supervised learning. That means that you always have an input and you always have a target output for you to use to learn. And one of the things that you usually use is a linear regression. Why? Why is that? Because that is the easiest formula for us to use. That's the easier one to take derivative of. And the way, but the word is not linear. That's the way you make the non-linear problem become linear is by dissect it to become very small section. Any small section, you take a line, you dissect a very small section, it become linear, right? At that section become linear. But then you don't transform that. Then you take linear, 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 linear. So you take y equal to xw plus b, and you plug in the next y1 equal to x1 plus b. What is the final y? It's still linear. And that's why you put in a activation and activation transformation after that. So, so now I'm going to go ahead and prepare my environment to be able to run. So on here, I say if you have a device, you have a GPU device, we can uncomment, and we don't need to uncomment. We just run uncomment and run it. On your environment, you actually have GPU. So go ahead and uncomment the second line and run it. If you don't have GPU, it's going to give you an error. So, but that's why, because not everyone have. So I comment it out to begin with. So your device right now is actually GPU. So now going into a very simple model. And I don't want to use MNIST or anything right now. I want to do a very basic math for you to see what we are doing. So in here, I define my number is my sample number. The dimensional in means what is the dimensional out. All we have is one dimensional right now. That means my x is just x. There's no x1, x2, x3. So therefore, W will be just W. And as we go on, you can increase. Just change this, but just remember, when you change it, your W have to match, like we say matrix application. So then, so I will create my input X is a random number that has 64 number with one dimensional. So I just have 64 number on this device, which is my GPU device. And then my Y is just Y equal to time 2x. So guess what is my W? 2, right? I purposely do that so that later when we run our model, we should see our learned W is 2. Purposely do that. And then what is our B here?
0.
0. Okay. So now I have my W, I have my X, I have my Y, I have my B. B is essentially 0. So if you recall the TensorFlow chart I talked about, you have to define your placeholder for X, Y, and also your variable for W. That's what equivalent to what we did in TensorFlow. And now I do a loop, but forget about the loop. Go into x dot mmw. That means mm means matrix multiplication. So I take my x, I times my w, and I get my y predicted. Okay, so that is this box here. I just finished that box. I compute my output. Okay, so now the next step I'm going to do is, if you look at the next step we need to do is do a loss. Okay, and here I just do a simple loss. Is a mean square error. I just take the different square and then sum it or mean it. It doesn't matter. Okay, and I call that my loss. So what I try to do is minimize this loss. Okay, you remember that when I say if I do x and y equal to x, you know that my w is 2. But when I initialize this w, I did not initialize to 2. I initialize to a random number because we want to exercise this learning. Eventually, I want to see this w converge to number 2. That's why I use this very simple method when we see. So now we have the loss. And now how do we minimize this loss? How do we minimize this loss? So if you know of any graph, what is your maximum point and minimum point? How do you get your maximum point and minimum point? You take the derivative of that. And then you set analytical way is you set it equal to 0. But here we don't want to solve an equation equal to 0. We we just take the derivative and we adjust that in a way that it approaches to zero. It's more like a try and error way versus a solving a way, right? So what we do here is, first of all, I try to find the derivative. So my loss, what is my loss? If you see y predict minus y, think of that as x. Think of that as x. So my loss is actually x squared, right? So my derivative of the loss with respect to whatever my x in this way is y predict minus y is 2x, right? Did you see why I get here? I don't have a blackboard. I can write. So think about this as x. Think about this as x, and that is x, and derivative of loss over x is 2x, right? So that is your x. But we want to find the derivative of loss over w, not loss over y predict minus y. Therefore, you have chain rule, right? So your loss is calculated based on y. So you have d loss over d predict minus dy. And then your dy is actually, your y target is a constant. So derivative of a constant is 0. So if I take derivative of this thing over x, over w, so xw, if I take derivative, y equals xw, if I take derivative of y with respect to w, what is the answer? X, right? And we don't have a whiteboard, but that's it. So when we talk about on this graph, I hope you get the picture clearer. When we say we do backward calculation, backward propagation, what do we mean? We mean that we take the derivative of the loss, because that is where the difference is, all the way to the very first w. If you have 100 layers, you will have to back propagate all the way to the very first w. Because when you calculate, you first calculate from left to right, first calculate from that w and go on to the next one, go on to that one, etc. So that is what called back propagation. Does that make sense? Yeah, with a whiteboard maybe make more sense. But this is a very simple loss function. Earlier you see the cross entropy loss function, y minus n summation of y times log or something. Think about taking that kind of derivative. It will be so difficult. And that's why the framework you just call cross entropy, and that's why you get there. And in PyTorch, you just call that. So go ahead and run this one. So you will see that the last print here is I print W, right? I print W, and W is actually 2. That means that we learn. You remember we initialize that to a random number, but then after we learn and we print that again, it is now 2. Okay? Okay. So if I take the same algorithm, the thing that I just do, so instead of, what do I do here? Instead of calculating the loss myself, I just call a function in PyTorch. So this function is called MSE loss. So I just take that function and call that function and calculate my loss. So in the next section, I'm just telling you that if you have a utility in this, use the utility. So once you have a strong framework, then doing a lot of programming might not be as difficult as if you do everything from scratch. So the next section is, I just use the predefined, I just replace that calculation that I did with this, calling this MS class. Yeah. You can run that, but then I just progressively show you how you do the formula, and then you go on, because if I just go on show you MS loss, you don't see the calculation, and now you do. The next one I want to do is, we keep talking about optimizer. So what is an optimizer? Optimizer, you remember, after you calculate the loss, and then we do all this derivative. Are we done?
No, that's okay, go ahead.
Yeah. And then we do this derivative, and then we adjust. I forgot to tell you earlier. Okay, so in here, go back to this. After I calculate the loss, I calculate the gradient. But I haven't tell you how I use the gradient. I skipped that. So the way I use the gradient is I subtract that from the W that I had before. That's how I adjust it. And this step that calculate the gradient and subtract that from the weight is what we call optimization. Subtract is very easy, because optimization means that when you want to adjust number, there's a million ways that you can adjust that number. You can adjust that by just subtract. You can adjust it by take log, take the ratio, and progressively adjust. And that's what, though all of in this area, that's what we call optimization. Okay, so so going on, I just replaced one section of the code at a time. So earlier I already replaced the loss function, right? In here, we replaced the loss function. Next, I will replace instead of calculating the gradient myself, now I am going to, if I use the loss function, let's go here. So here I calculate the loss. And here when I use a loss function, I use an MS loss function. If I use a defined loss function, I don't even need to calculate the gradient. I just need to call dot backward, and it will do all the backward calculation for me. Okay, so you get the idea. So you're replacing your loss calculation with a loss function. You're replacing the calculation of a gradient and the way how you adjust weight by an optimization function. Okay, and then going further, it just, the next step I'm going to replace is, instead of calculating the model myself, I just call one of the linear functions that they have. Okay, in here, maybe the last step here. So I use a built-in loss function. Therefore, I never even have to calculate gradient. I just need to call loss dot backward. I don't need to say loss, my loss with respect to x, respect to w, etc. It will calculate for me. And in here, instead of doing the matrix multiplication of x times y, I just call a NN linear. Or I can call NN.CNN, or I can call any model that from the library. What you need to pay attention is the dimension. Like anything, matrix multiplication, dimension is the most important thing. And optimization, and I just call it optimization. And then you can run it. And now going back, what is deep learning? So I show you only one formula, and now I show you a stack of things different type of formula that you take your input number, you go through one formula, you go to the other one, you go through, and when you go to like a number of layer, it becomes a deep neural network.
Yeah, I learned it.
Does it help?
Yeah, I learned it deeply.
Okay. So I think the rest, I think I get the essence. I discussed the essence.
You're doing it very well. Excellent.
Yeah, the rest of that, I don't know the time, but the rest of that, I just substitute one thing at a time and introduce the concept one at a time for you to see. And now I go to 2 layer, and then at the end I go to 1. Yeah.
Will this distributor be available after the workshop?
Yes.
Okay.
But the notebook will be available, but the environment is not, because this is university.
I see.
that
Okay.
I need to return after this.
Okay. That's
Yeah. I believe you can run it on x86. You have a Jupyter notebook, you can just call it. Yeah. I do this more like for people that know TensorFlow, you can have quick reference of how PyTorch does things. And if you don't have that background, then you have a like introduction, like from easy to hard, like kind of thing. And I hope it helps. Yeah?
Yeah, it really helped create like a appreciation for what looks so simple, like identifying a number. Like
Oh, yes.
takes a lot of work to do it.
Yeah. So like here, you also have this. It's called PyTorch Embedded Basic? No. It's called use PyTorch to predict a random. Can you go there?
Sure.
You should have that too. So you know that your post office, when you write the address, they recognize that your zip code, right? Your bank, your bank. But I think these things is neural network. But more and more, because now it can be as you get more data, more handwriting, you just feed it, you just do additional testing. So your accuracy becomes higher and higher and higher. So you can go ahead and run, you go to cell and you say run all, go ahead and run it. So this is like another implementation, but using PyTorch on MNIST. And you also have the TensorFlow in there. But this is not a programming class, it's more like giving you the concept, and hopefully you grab the concept. Yeah. Okay.
Thank you.
Did you see any? Anyone